If you take a seed from your orange and plant it in the ground, it'll grow into a tree. But to get fruit, you might have to wait as long as 15 years, which is kind of a bummer for the impatient types among us. You can't blame the plant, since it has to grow up and go through the plant version of puberty before it can start making flowers and then fruit. But don't despair, OJ lovers, because there's an age-old trick called grafting that can shorten the wait to about 3 years. And it can do all kinds of other things too. All you do is smoosh part of one plant into part of another plant, and you get a super plant, which seems awfully easy. But even weirder, it turns out to be a low-tech way of tinkering with a plant's genes. It just goes to show that long before anyone invented modern gene editing, humans have been finding ways to manipulate plants into feeding us on our own terms. Grafting is as simple as taking a root from one plant and sticking it with a shoot from another. With enough pressure and moisture, the two should fuse into one. It almost always works with plants of the same species, like between apple varieties, but it can sometimes work with different species. In fact, it can sometimes work between plants of different genuses, like pear and quince. If you take an older shoot from a tree that's already producing fruit and merge it with a younger root, the shoot maintains its mature state. This works with even minuscule shoots. In vitro grafting takes a shoot from a mature tree that's just 1.5 millimeters long and grafts it onto the roots from a just sprouted seedling. It's not only a shortcut to getting earlier fruit, it's also a way to get rid of citrus-infecting viruses. That's because viruses and other pathogens usually don't infect the very tips of a plant's shoots. This micrografting is a pretty recent development, but grafting in the more conventional sense is far from new. People have been using it for at least 2,500 years. No one is sure how fruit growers first came up with the idea, but they may have taken inspiration from a similar process that can happen naturally when the roots or branches of neighboring trees meet and fuse. But regardless of how grafting started, over the centuries, people have come up with all kinds of cool ways to use it. These range from building fanciful and artistic forms to manipulating a tree's size and fruit characteristics to engineering plants that resist cold, drought, or deadly diseases. In the late 1800s, grafting even saved the entire wine industry from being wiped out by an insect pest. This pest came from the Americas, and most European grapes had no resistance to it. But growers found although American grapes were no good for making wine, their roots resisted the pests. So, grafting shoots from European wine grapes onto roots from American grapes made the entire plant resistant. Today, nearly all wine grapes are grown this way. But by far, grafting's main use, both early on and into today, is asexual propagation. Basically, it's a way to take a tree that produces great fruit and clone it over and over. For many types of fruit trees, scientists think this was an important early step in domestication. That's because most fruit trees don't grow true from seed. That means if you plant a seed from your red delicious apple, it'll grow into a tree. But it'll probably make a totally different kind of apple. And after waiting a decade or so for it to start making fruit, you may find that it doesn't even taste good. It's easier to develop true breeding varieties of plants with shorter life cycles because we have the patience to do that. But for slow maturing plants like apple trees, it's much faster to pick a specimen that makes good fruit and clone it. Plus, if someone invents a better variety, or if you're a fruit grower and consumer tastes change, you can try grafting new shoots onto your established trees to get back in the game faster. But it's not just good fruit we're after. A lot of the work over the centuries has gone into developing the plants that provide the roots, also known as rootstock.